Hello, and welcome to Seeds of Literacy math session on working through systems of equations with graphs. My name is Mike Ferentz, and I hope to share with you over the next 30 to 40 minutes more ideas about graphing equations, starting with linear and working up to quadratic. I would like to share my screen with you now, and here we go. Show you my PowerPoint that I've created here. Again, our title is Working with Systems of Equations and Graphs. So we'll talk about graphing a line, a linear equation, plotting points, back to graphing a line, and then graphing a quadratic equation. Let's just start with a quick review of graphing. So in a previous lesson, we talked about graphing a line with the equation y equals 2x plus 5. And by using that equation, we came up with some ordered pairs by entering in values for x of 1, 2, 3, and 4. And we came up with these ordered pairs, 1, negative 3, and I'm going to graph those for you. With my drawing tool. So we got 1, negative 3, which is 1 to the right and 3 down. And then the next ordered pair is 2, negative 1, over 2, down 1. This is just a review because I've done this in a previous lesson, but just wanted to call attention to graphing an equation. And then a third ordered pair is 3, 1, 1, 2, 3, up 1. And then a fourth is 4 over 1, 2, 3, 4, up 1, 2, 3, and you can see by graphing those 4 ordered pairs, we've created a line that is mostly straight. Okay. So moving on, let's go to next part of the lesson here, and we're talking about just the basics of graphing a linear equation. Let's get rid of that. Okay, so this equation in this example is 3x minus 1 is an example of a linear equation. And the same thing as what I just showed you from the review. It's you plug figures into for the x and you come up with a y. So this problem is asking you to choose 3 values for the independent variable, which is x, and then determine the matching value for the dependent variable, which is y. And then plot those points on a coordinate graph and connect them. So it's a review of what we just did, but here in the notes from the packet, it shows that the problem is done for you. So the example is graph an equation that is y equals 3x minus 1 with x being 0, 1, and 2. And so you solve the equation for those 3 values. So when x is 0, you plug it in there. 3 times 0 minus 1, you get the ordered pair 0 minus 1. When x is 1, 3 times 1 minus 1 equals 2. I'm plugging 1 into this equation, and I get the ordered pair 1, 2. And then when x is 2, plug it into the equation, you get y equals 3 times 2 minus 1, which is 6 minus 1, which is 5. Now you got these 3 pairs of values in the table over here. 0, 1, 1, 2, and 2, 5. So we've written those down as ordered pairs here. Point A equals 0, 1, which is this, 0, 1. Point B is 1, 2. Shown here, when we plug the 1 into the equation, we have 1, 2. And point C is 2, 5, because when we plugged 2 into this equation, 3 times 2 is 6 minus 1 gives you 5. Then they went over here and plotted the points. So the first point is 0, 1. And so you go neither way, left or right, but just down 1. That's 0, 1. The second point, B, is 1, 2. Go over 1, up 2. There's B. And then the third point is 2, 5, which is point C, over 2 and up 5. And as you can see from the notes from the text, their line is a lot straighter than the line that I drew in the last example. That's good news. Okay. Continuing on. Now, the text from the notes is asking us to do a couple of problems with 2 new graphs. So since the topic is graphing systems of equations and graphs, we'll just continue on with that. We're going to just review what the x-intercept and the y-intercept are. So if I have, let me get my pointer back here. My pen. If you have a line that goes through like so, that was just arbitrarily chosen there. If it crosses this y-axis at the point 3, then the y-intercept is 3. That means it intercepts this line, it crosses this line at the point 3. And in this graph that I just drew, it crosses the x-axis, which is the horizontal axis, at the point -2. So if you saw this line, you could say that it has an x-intercept of -2, and it has a y-intercept of 3. But that's not the equation we're working with. That's just an example of the x and y intercept. So I'm going to get rid of that. And start with this, this equation, y equals x minus 2. So let's go back to this table and we'll plug in these 3 values for x, 0, 2, and 5 into this equation and come up with y's. And when we do, we'll have 3 sets of ordered pairs to plot and then draw the graph. So when we plug in 0, we have y equals 0 minus 2, which equals -2. So I can write in there for when x equals 0, y will equal -2. Okay, now let's plug in x equals 2. So y equals, I'm sorry, not -2, 2. Let's plug in 2. 2 minus 2, and that's going to equal 0. So when x equals 2, y equals 0. 0. And now finally, let's put in 5. When x equals 5, plugging it into this equation, y equals 5 minus 2. 5 minus 2 is 3. Back to this table, plug that in. We've got 3. So now we've got 3 sets of ordered pairs which make points. And they're right here in the XY table. They are 0, 2, I'm sorry, 0, -2. They are 2, 0, 2, 0, and 5, -3. I'm going to move over to the graph here and plot those points, 0, -2. So 0 is your x value, so you stay at 0, you don't go to the right or the left. And your y value is -2, so you start here and go down to, here's your first point. The next ordered pair of the next point is 2, 0. And so let's go over to the graph and plot that. And so 2 is the x value. Let's move over on the x-axis 2 points. And we're not going up or down any because the y value is 0. And finally, we have the points 5, -3. So for the first value, which is the x value, we move over 5 places to 5. It's not -3, my mistake. It's 3. Sorry about that. 5, 3. And with a nearly straight line, you can connect those 3 points and you're done with that problem. Okay. Let's erase that. Go on to the next problem. Sorry, that problem 2. We'll just run through. Oh, I'm sorry. I forgot to write the x-intercept and the y-intercept. Well, if you recall, it crossed the x-axis at 0, and it crossed the y-axis at 0. That's your y-intercept, and the x was at 2. We'll fill those in the next problem to be sure. So let's.
Hi, good morning.
Hi, how are you?
Sorry, a little late.
You're completely fine. My name's Mike Ferentz, and I am just doing some graphing of equations onto a graph. So if you'd like, I'll just continue on here, and you can ask any question at any time. Okay?
Okay.
Okay. So what I'm doing here is I'm graphing this equation onto this graph. And I'm doing that by just adding any values I want for x. I can choose any values for x, plug it into that equation, find 3 points, and then plot it onto that graph. So I'm going to use my pen for that. And I'll pick just very simply 1, 2, and 3. Can you see that okay?
Yes.
Okay. So I'm going to start with the first point here, x. And I'm going to plug that x into this equation and come up with a y value. So the equation is y equals x plus 2, and I'm plugging the x value of 1 in for x, 1 plus 2. And I come up with 3. So my y value, when x equals 1, then I know that y equals 3. Okay?
Okay.
Next, I'm going to plug in the x value of 2 into the same equation. I'll have y equals 2 plus 2.
So the next y value is 4.
Correct. So I'll just put that back into this table up here of 4. And I'll plug one more point. If you have a linear equation like this, if you choose 3 points, you can make it into a graph. I'll plug in 3. 3 in for the x. Plug the 5 in here. Now you see I have 3 sets of ordered pairs or points for the plot, which is 1, 3, where 1 is the x value, 1 is the x value, 3 is the y value, 2, 4, where 2 is the x value, 4 is the y value, and 3, 5. So I simply move over to this graph and plot these 3 points. 1, 3. So this is the y-axis. This is the x-axis. The first one I look at is the x value, which is 1. And so I start at the origin, which is 0, 0. And because the x value is 1, I move over 1. And now the y value is 3. So since the y value is a positive 3, I move up 3. 1, 2, 3. And there's my first point. Okay?
Okay. She's going to give you the music. There you go. Well, you got to pee? Go pee and come back. Hurry up. Don't touch nothing. Don't say nothing. Just go do it.
Okay, so
I apologize. I was talking to my daughter. I'm sorry.
No problem at all. That's completely okay. So my second point is 2, 4. Same thing, I'll come over to the graph. For the x value, I'll go over 2. And for the y value, I'll go up 4. See how I did that?
Yes.
Okay, and then for my third point, it's 3, 5. I'll go over 3 and up 5, which is right there. So now I've got 3 points plotted on there. I could take any number I want and plug it in there, and that point will fall on this straight line. That's pretty straight, not exactly straight as I could draw it with my mouse. But so as you can see, if I plug in any value for x, it's going to fall on this, and the value I get for y will fall on this line. Okay.
Okay.
So had I chosen 0 for x and plugged it in there, 0 plus 2 is 2. So this line, if it were straight, it'd actually go right through here. It's 2. And if I chose negative 3, negative 3 and 2 is negative 1. And so it would fall right here.
And that's a positive slope, right?
That's a positive slope. And if you are familiar with the formula for a straight line, is y equals mx plus b, where the slope is m, and the slope for this is over 1 up 1, over 1 up 1. So it's going to be 1 over 1, rise over 1. I'm sorry, that's a 1. 1 over 1, and so the slope is 1, positive 1.
How did you figure out the slope is 1 over 1?
Because when I move from one point to the next, I'm going up, I'm going over 1 and up 1, over 1, up 1, over 1, up 1. That means.
Okay, so you would start at the y-intercept, which is the 2.
You can start anywhere. Yeah, you can start anywhere on this line, and to get to the next point, you determine how many over and how many.
Okay, and then you would go over 1, and you go over 1 and go up 2.
Well, it's up 1. I'm sorry, it's up 1 over 1, up 1 over 1.
Oh, 1 over 1.
Mm-hmm. And actually, I have another slide in this presentation that talks a little more about slope.
I really kind of don't get it. How did you get So to find the slope, you would start at any point on the line.
Mm-hmm. Right.
Okay.
And so you can start at any point and you pick the change in y and the change in x. Change in y, which is 1, up 1, over the change in x. Which is 1. So you can also determine the slope just simply from this equation right here. Because this equation is y equals x plus 2, and since there's no number in front of x, the number is 1. So if you look at this equation, y equals mx plus b, the slope is m. So just from this equation, you can see that there's a 1 there, because 1x is the same as x. The slope of that line is 1, positive 1. Now, if this equation was y equals 2x plus 2, your slope is 2. So you'd go up 2 over 1, up 2 over 1, up 2 over 1, like that. Make sense?
Okay.
So you can see the slope from the line or from the equation.
No. Sorry, yes, baby. She said no, baby. Somebody say no. You listen. Hello.
Yeah, hi. Does that make sense?
I'm sorry.
Um, actually, two slides later down here, I have more discussion about slope that I can share that might help. So I'm going to erase this and move on to the next slide, but I will address the idea of slope, and you can see what I'm talking about. So I'm going to erase this, and I'm going to move down to here. So finding the slope. Sorry about that. Okay, so finding the slope. So if you're already familiar with the concept of slope, as I mentioned, it's the change in the y value divided by or over the change in the x value. So when you walk uphill, it's a positive slope. When you walk downhill, it's a negative slope. So a graph line has either a positive or a negative value. Okay. So let me get my drawing tool back in here. So any line that goes uphill is a positive slope. Any line that goes downhill is a negative slope. And the slope is, so if this was a graph, determines the number up, the number over, up, over, up, over. So this looks like it's 1 up, 1 over, 1 up, 1 over. So that's going to have a slope of positive 1. This one is 1 up, 1 over, 1 up, 1 over. Same thing, and it's going to be a negative 1. Get rid of that. And I think I have some examples on my next slide. I do. Okay. So this slide here is an example of slope, and in this graph, it's going. You see, it's a straight line, similar to the ones I've shown. And in this graph, it's going 2 over and 4 up. So you've always put the the change in y on the top. So the change in y in this one is 4. So as I go from this point to this point, I'm going up 1, 2, 3, 4. And then when I go from this point to this point, I'm going over 2. So up 4, 1, 2, over 2. So the change in the y value is 2. And 4 over 2 equals 2. The slope equals 2. And the y-intercept for this is 0. So
Okay.
if I want to plug that into that equation, y equals x plus b, I now know that my slope is 2, and I know that my y-intercept is 0 because it crosses.
Good morning.
Plug in 2 here and 0 here, and I come up with the equation y equals 2x plus 0, which is simply written as y equals 2x. So for this graph, without knowing the equation, I determined the slope and the y-intercept, and I was able to come up with the equation for this graph. Does that make sense? Okay, I will move on. Let me get rid of the drawing. So here, this is just a quick review of slope. So you start with a linear equation of a line. You identify the slope by the number, the change from the number up to the number over is your slope. So this is your y, x, and this is your y. So the change in y, either positive or negative, over the change in x, also known as rise over run. Rise meaning vertical, run meaning horizontal. Then you identify either the x or the y-intercept or both, and then you can graph the equation. And when you know the y-intercept, that becomes the part of the equation, y equals mx plus b. And b is your y-intercept. So b is the point where the graph crosses the y-axis.
Right.
And then, so you can start with an equation and make a graph, or you can start with a graph and figure out the equation either way, as long as you can figure out the slope and the y-intercept. So you could take any equation, you can graph it on here, and you could take any graph and figure out the equation simply by figuring out the slope and the y-intercept. Okay. So I'm going to erase that, and I think I have an example. Yeah. So let's go back to the beginning here. I have this equation in here, y equals 2x plus 5. And I plugged in these 4 values, 1, 2, 3, and 4. So when I let x equal 1, plug that into the equation, I got 2x, 2 times 1 minus 5 equals a negative 3. So I came up with the ordered pair 1, negative 3. 1, negative 3. 1, negative 3. And then when I plugged in 2, 2 times 2 is 4 minus 5 is a negative 1. So I go over 2, down 1. And then when I plug in 3, 2 times 3 is 6 minus 5 equals 1. So I have the ordered pair of 3, 1. So 1, 2, 3, up 1 is the positive 1. And then when I plug in 4, I have 8 minus 3. I'm sorry, 8 minus 5 equals 3. I have the ordered pair of 4, 3. 1, 2, 3, 4. 1, 2, 3. So now I have the straight line. That's supposed to connect there. With a slope of 2, which means for every point I go up 2 over 1. Up 2 over 1. So I have a slope of 2. So in this equation, y equals mx plus b. I know that I have a slope of positive 2. Y equals 2x. And you can see it crosses, it's supposed to cross down here at 5. It crosses the y-intercept at 5, negative 5, right here. So my b is negative 5. So this is the equation. This is the equation. This is the line. Slope of positive 2, y-intercept of 5. I'll get rid of that. And I did one other, I'm going to go back to it. Sample. Right here. This was a little more simple. Y equals x minus 2. So we could just do this in our head. When x equals 0, y equals 0 minus 2. Equals negative 2. And when x equals 2, y equals 2 minus 2 is 0. And when y equals 5, when x equals 5, we have y equals 5 minus 2, which is 3. So we have these 3 points that we can plot, 0, negative 2. So with the x value of 0, we go down 2, because the y value is negative 2. When x equals 2, 1, 2, the y is 0, so it doesn't go up or down, it goes right there. And when x equals 5, we're going up 3. I wish I had a ruler on here. So you've got this equation here with the slope is 1 minus 2. And so your slope is 1 and your y-intercept here is 2. And you can see that when it crosses the y-axis, it's negative 2. When it crosses the y-axis, it's crossing the y-axis at negative 2. So for your equation, y equals mx plus b, you know that you have a slope of 2. And you know that you have a y-intercept of negative, my mistake. The slope is 1. Sorry about that. Y equals x plus minus 2. because your y-intercept is -2. So your y-intercept is -2, and your x-intercept is where it crosses the x-axis, and we can see it crosses the x-axis at 2. Any question about that?
No, no questions. I understand it.
Okay. So I want to show you one last graph.
I'm sorry, say that again.
I'm going to show you one more graph of an equation that is not a line, but it is a quadratic equation. And that'll be the last slide that I have here. Okay, so you can see this. I have the equation y equals x squared. Okay, so I'm going to plug the values in there. So this equals y x squared. So when I plug in 0, 0 times 0, 0 squared is 0. When I plug in 1, I get y equals 1 squared, which is 1. When I plug in 2, I get y equals 2 squared, which is 2 times 2, 4. When I plug in a -1, I get y equals -1 squared. -1 times -1 is 1. And then when I plug in x equals -2, I get y equals -2 squared, which is 4. So now I will plug in these 4 points, 0, 0, 1, 1, 2, 4, over 2, up 1, 2, 3, 4, -1, 1, and -2, 4. So I do not have a line. Instead, I have a graph that looks like this.
Does that graph have a certain name?
Yes, it does. It is a parabola.
Okay, I think I heard of that before.
Okay. It's a parabola. And this parabola is an example of a quadratic equation. Because it's a quadratic equation, because it has an x value that is raised to an exponent, y equals x squared. So it's not a line, but it is a parabola. So this parabola continues on infinitely in both directions. Now, there's one interesting point here about a graph of a function. A graph is a graph of a function only if you drew a straight line. And it only intersects, you can draw a straight line anywhere, and it's only going to intersect this graph in just one point. No matter where I drew a line, it's only going to cross this graph in one point. If it crossed it in 2 points, let's say I had a graph that looks like this. A straight line is going to cross that in 2 points. That is not a function. There's not a function for this graph. That's a little bit of a difficult concept. Even in higher math, it's a little more difficult to understand, but I have a hard time with it too. But the important thing is that now we have a graph of a quadratic equation, y equals x squared. Now, you can change that, the looks of that parabola, and I'll do that. If you change this to y equals 2x squared, it'll still be a parabola, but it'll look different. So let's plug it in. Oh boy, sorry. Y equals 2 times 0 squared. And it's still going to be 0. Let's plug in 1. Y equals 2 times 1 squared. It's going to equal 2. If I plug in 2, I don't know why that thing does that. This takes off on its own. Y equals 2 squared. 2 times 2 squared.
So on the y-axis, it would be 4.
Yeah.
That's right. Okay.
So it's going to be actually 2 times 2 squared 4. It's going to be 8. So that's
okay. Okay.
The negative 1, I got negative 1 squared times 2. That's 1. 2 times 1 is 2. And then for negative 2 squared, it's going to be 8. Because that's going to be 2 squared. Negative 2 squared is 4 times 2. So now let's look at what we have here. 0, 0. 1, 2. 2, 8. And then negative 1, 2. And negative 2, 8. So now, you remember what the last one looked like? It's the same thing. It's a parabola, but it's narrower. So if you recall from the last equation, y equals x squared, it looked more like this. So when I have the 2 in there on this equation, it makes the parabola narrower. Also, if I was to with the same equation, if I was to add, let's say 2 here, or any number here, what that would do is that would take this, it would take this same parabola, 2x squared, and it would just move it up to here. So it would look like this. Got the same width, but it would just cross the y-intercept at 2. Any question about that?
No, but it just helped me focus on paying attention to the exponents, because here we had 2 times negative 2, which is negative 4 times 2, which is 8.
Well, negative 2 times negative 2 is positive 4. 2 negatives.
Okay.
Yeah, so it's an
8. Negative 2 times 2 is positive 4.
Negative 2 times negative 2 is positive 4. Yes.
Okay, negative 2 times negative 2 is positive.
And then times 2 is 8. Now,
okay.
That makes sense?
Yes, that makes sense.
One more thing I'll add is that if I was to change this equation right here, if I was to change this equation to a negative 2, so if I had the equation y equals negative 2 times x squared. So now it would still, I'm gonna change that to purple. It would still start at the origin. And then, so if you plug the 1 in there, 1 squared is 1 times negative 2 is negative 2. So it would be like 1, negative 2. And then the 2 would be 2 squared is 4 times negative 2 is negative 8 down here. Same for the here. If I take negative 1 and square it times negative 2, I'll get negative 1, negative 2. And then also negative 8. So when you add a that's rounded, by the way. It's not a square. When you add a negative,
Okay.
what it does is it affects the parabola downwards.
Okay.
So the important thing to remember is you take your equation, plug in your x values, come up with a y value, move it over to the graph and plot it and see what it looks like. And if you're starting with the equation, you can always get a graph. It's a little harder to take a graph and figure out the equation, but eventually you can do that.
Say that again.
If I'm starting with the equation and making it into a graph, I can always do that by plotting the points. So if I have whether it's y equals x squared, or if it's y equals 2x squared, or if it's y equals negative 2x squared. If I have any of these equations, all I have to do is plot in these points here, plug in these points, come up with a y value, and I have ordered pairs that I can turn into points that I plug in on the graph, like I did here. Once I have the points, then I can do the graph. It's always, you can always take an equation and move to a graph. You can take any equation and turn it into a graph. Okay?
Okay, can we do another one?
Sure. Absolutely. So I'm going to erase all of this. I'll erase all of this. And you want to tell me an equation and I'll draw it?
Sure. Y equal x plus y equal x plus 3.
Sure. Okay, so because there's no exponent here, it's not x squared, it's just x, that's going to be a line. It's going to be a straight line. You know that.
Yeah, you can get water.
So if I plug in 0 over here, all right, equals 0 plus 3. X equals 0, y equals 3. Now I'm going to plug in 1. When y equals 1, when x equals 1, I've got 1 plus 3.
4. Yeah. Yeah.
And plug in y equals x is 2 plus 3 is 5. Sorry, that's a 3. 5. Now let's go on the negative side. When x equals negative 1, I have y equals negative 1 plus 3. And that is a positive 2. And when y equals -2, I've got y equals -2 plus 3 is 1. So now I've got 5 points that I can plot. First one is 0, 3. So I come over to the graph. So since the x value is 0, I don't go either way. I stay right on this line. And the y value is 3, so it's going to go right there. So the next set of points I have is 1, 4. So I go over 1 and up 1, 2, 3, 4. When I have 2 and 5, I go over 1, 2 and up 1, 2, 3, 4, 5. When I have -1, 2, I go over -1 and up 2. And when I have -2, the value is 1, so I go over 2 and up 1. So you see I have a nice straight line there. Even though I'm not drawing it as a straight line, it's a straight line. And I have this equation of y equals, it's actually, let me try to get that in there a little better. I have this equation of y equals x plus 3. So if I go back to my sample of slope y-intercept plus b, I know that looking at this, there's a 1 there. So my slope equals 1. And I can verify that because the rise over run is up 1 over 1, up 1 over 1, up 1 over 1. It's 1 over 1, which equals 1. So my slope equals 1. And my y-intercept it crosses the y-axis at 3. So my b equals 3. And the y-intercept is 3. The x-intercept is -2. Okay?
Okay.
So that is an example of a linear equation with a slope of 1, y-intercept of 3. And you don't really even need to do 5 points. If you do 2, you can, if I had just 2 points, I can see that it's a straight line, but it's always better to do at least 3. In this case, I did 5.
Could you show me how you found 1 for the slope?
So if you look at the equation is y equals x plus 3. So and from this formula, y equals mx plus b.
Mm-hmm.
If there's no number here like 2, 3, 4, 5, if there's no number, it just simply means the number is 1. 1x. You can also determine slope because on this line, when you're for every you have the slope. Up 1 equals 1. Slope is 1.
Okay, right. Okay. Okay, I get it now because the variable x is 1. So you started at 3 and you went over 1. You went up 1 and over 1.
Yeah.
Okay, okay, right. Okay,
Y-intercept is 3.
right. And the x is 1.
Yeah, and I could start any place on there, and I could literally, this line goes on to infinity in both directions. So
So when you say start from any place, what if so how could you if you start from any place, is it possible that you could get the wrong answer?
no, no. So for example here, if by starting, I say you start by choosing the value for x. So I chose these 5 values here for x. I could choose, say, 20.
About to listen to music.
20, that would be way out here somewhere.
Mm-hmm.
try to explain using this equation. Y equals 20 plus so my y value is 23. So 23 way over here 20 and up 23, and I would still, my point would still be on this line.
Okay. Okay.
So
Okay.
no matter which value you choose for x, you will get a y value that is on this line.
Okay.
Same for y. I mean, if you any y value, you can solve for x, and that ordered pair, that point would still be on this line.
Okay. Now, does the line stay consistent because the y-intercept is 3?
Well, in this case, it's 3, but it stays consistent because the slope is 1.
Okay.
Now, if the y-intercept was 4, or let's say if the y-intercept was 7, this exact same line would be parallel to this line, except it would cross the y-axis. It's the same exact line, up 1 over 1, up 1 over 1, except instead of crossing the y-intercept at the y-axis at 3, it's crossing the y-axis at 7. Now, I can also have a line with a negative slope, and it says, say that it's -1. Then if the slope is a negative slope, then it's going down 1 over 1, down 1 over 1, down. That's a slope of -1 over 1, which equals -1. So this line right here has a slope of -1. It has a y-intercept of -1. It's negative because it's as I mentioned, it's going downhill. That's negative. It still goes on to infinity in both directions. So the same property holds true that no matter which point x you start with, if you plug it into this equation, you'll end up on that line. So the equation for this line is going back to our slope y-intercept formula. The formula for this line is y equals -1x minus 1, because it's crossing the y-axis. It's crossing the y-axis at -1, and it has a slope of -1. Okay?
Okay.
So do you have any other questions at all that I can help you with? If you do, I will be on at 10:30.
Hey, Lord, say that again.
At 10:30, we will be on the open table section.
Oh, to call you guys.
Yeah, you can go on my open table session on GoToMeeting at 10:30, and I can answer not only questions about graphs, but any math questions at all.
Okay. Okay.
So I'll be back on at 10:30
Okay,
because
cool.
my recorded session is only an hour and it ends at 1 o'clock.
Okay.
All right.
Yeah, I definitely, that helped me understand plotting the equations on the graph, because that was something I struggled with. But I have a better understanding of it now.
Okay, and as I said, if you want to work on some more of those problems, just go on to the GoTo 10:30. Be on there every Tuesday at 10:30. My name is Mike Farron. Happy to work with you.
Every Tuesday at 10:30. What?
This is my open table training tutoring session. So if you go on
Okay.
to GoToMeeting at 10:30, I'll be on there. for math, and to answer
Right.
any questions as well. So the session we just completed now is a recorded session, and I'm going to stop recording, and then this lesson will be found on the recorded lessons section of the Seeds of Literacy website.
Okay.
Okay.
Cool. Thank you so much.
Thank you. Nice talking to you. Maybe I'll see you on the open table session at 10:30.
All right. Cool.